Hi, hello. Welcome to VHDL Basics. Today we are going to see about how to implement the clock divided by 3 with 50% duty cycle in Verilog HDL. So this is the circuit diagram of the clock divided by 3 module. There are three flip-flop used here and one AND gate, one AND OR gate are to implement the D naught and clock out respectively. So the first two flip-flop are using clock rising edge, and the last flip-flop are using the is using the neg edge of the clock. So why we need to use the neg edge of the clock at the for the last flop, right? To attain the 50% duty cycle. So if we are using passage of the clock for the last flip-flop also, we will get the divided by 3 clock, but that is not 50% duty cycle. So I will simulate both the things and I will show you the clock out waveform so that we can understand clearly. So now we can see how to implement the this circuit in Verilog. So module name is nothing but clock div underscore clock underscore div underscore 3. So there are two inputs, clock and reset, and output is nothing but clock out. There are three flip-flop used here, right? So we need to declare reg of three different variable. Here q naught, q1, q2, and wire to implement the d naught. So the first always block here we are using for to compute the first two flip-flops, to implement the first two flip-flops. So q naught is nothing but d0 whenever the rising edge of the clock. So q0 will be assigned to q1 whenever the rising edge of the clock when reset is deasserted. Okay, the third flip-flop here we are going to implement as neg edge of the clock, right? So every neg edge of the clock, Q1 will be assigned to Q2. Okay, and then we need to compute the D0. So if you see the circuit diagram, Q0 bar and Q1 bar is nothing but the D0. So for that, I am using assign statement to compute to implement the AND gate. Also, I am using assign statement for implement the OR gate for clock out. So clock out is nothing but Q1 or Q2. Okay, this is the Verilog module. So first I am going to simulate with this neg edge of the clock. See here, if you see, there are three clock pulse, input clock pulse to required to compute the clock out for the one clock pulse. So if I measure that clock out rising edge to rising edge of the next clock, that is 10 megahertz. So if you see the input frequency is nothing but here 30 megahertz. So divided by 3 is nothing but 10 megahertz. So we are getting 10 megahertz clock with duty cycle of 50%. So now we can change passage to neg gauge, and then we can see the waveform how that is impacting the duty cycle. Now I am going to change neg gauge to passage, and I will simulate this particular thing and I will show you the waveform. If you see the waveform here, here also there are three input clock pulse used to attain the one clock pulse of the output, but the duty cycle of this one is uh, not 50 percentage. So to achieve 50 percentage of duty cycle, we need to use the neg gauge for the third flip flop. Hope you enjoyed this video. Please like, share and subscribe this channel for more videos.